some more participants are coming. For this, I'll share the screen. What we will be discussed today. Okay, actually, I today didn't get the time to create the PowerPoint presentation, so I just copied the figures from the internet or from the other books or some slides, basically. Okay, so you just have to cooperate this in that particular presentation, but it's very important for all of you because today we'll discuss in big data analytics very important topic, introduction to Hadoop. Okay, basically last time as we have discussed the Hadoop ecosystem in which we have discussed about the all the components in details about in detail all the components of the Hadoop ecosystem, and as to become a big data programmer, a big data analytiker, then you should have to uh, know the uh, all the components very well. Okay, and you know the details of the all the components very well. Okay, so let's start with the introduction to Hadoop. Okay, so these are the agenda of that particular topic, and so introduction to Hadoop, in which we'll discuss limitations and solutions and of traditional system. Okay, and then we'll discuss motivation for Hadoop. Okay, then we'll discuss history of the Hadoop and benefits of the Hadoop, basically. Okay, and in detail last time we have discussed Hadoop ecosystem, so I just go through and just introduce about the Hadoop ecosystem again in that particular lecture. Okay, and then we'll discuss Hadoop architecture, that in which we'll discuss the first version of Hadoop architecture, 1x core components. Okay, that is basically just similar to the that we have discussed in the Hadoop ecosystem, basically. And there is a little bit difference between in Hadoop 2x core component, basically. Some advancements are there. Okay, and then we'll discuss fundamentals of Hadoop in at last. Okay, so this is going to our agenda. Okay, so let me start the first step to lead to the Hadoop, basically. And from this slide, so this is very this one is showing this is a very traditional history system while solving the big data problems. Okay, because of very expensive to store data, which was now very expensive business, because so we have to use Hadoop to lower our cost. Okay, the storage we are doing in traditional system, we are using in the traditional system were also not flexible also. So as when we use particular server, we have to use particular database to uh, get the respective data, then fetch the information using Hadoop capability. Okay. Uh, so this one basically the we know that from this diagram that when we fetch the data, Hadoop is capable to store terabyte of the data, basically. Okay, and can and be able to store at lower cost also. Okay, so enhance in here in the traditional system where uh, uh, this is unreliable to fault tolerance to do occurs that lot. Okay, so if one of the system, what is basically the fault tolerance? We know that if one of the system failed to create it, uh, 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 then it will be in the disaster, basically. Okay, so the fault tolerance where a node goes down, jobs are automatically redirected to other nodes in the Hadoop. Okay, but basically this is not possible in the traditional system, while in the case of the Hadoop system, that handle the fault tolerance basically very well. Okay, means if one of the job fail, okay, then the automatically redirect this that particular job or that particular jobs are redirected to the other another nodes, basically. Okay, in the Hadoop system, and we will compare the scalability is an application dependent. So we dependent on a particular application. So okay, so one application can be synchronized with all the others, but here we can see that have a expensive infrastructure. Okay, that have a expensive infrastructure means that provide low cost and commodity server inflexible storage. We have capability to store terabyte of the data and be able to add more storage at low cost. Okay, varied and unreliable fault tolerance. When a node goes down, jobs are automatically redirected to another. And scalability is application dependent, means scale up to hundreds of servers, and they can be added incrementally on the need basis. Okay, so these are the left side we have a limitations of traditional system, and on the right side we have how the big data solve these problems basically. Okay, so this is basically the comparison of traditional system and how the big data solve these problems. Okay, next, what is the motivation for the Hadoop basically? Okay, motivation for the Hadoop, in that particular we can see dividing the, from here we can see that we can see the dividing the large problem, because when we are discussing about the parallel computing and distributed computing, okay, so we can see dividing the large problem into smaller one and solved concurrently. That is, this is called parallel computing basically, and connecting multiple machine together for storing uh, the big files. Parallel processing occurs with data locality as it share parallelism used in various technology like in the grid computing or in high performance computing. Okay, so if you look at this graph in that particular diagram, one client is dependent on only one data set. Okay, so in all, servers are loosely coupled. Okay, from here we can see that all the servers are loosely coupled. So amount of the data in the server is increasing, so it will fail to perform well. Okay, and hence we have to propose for the Hadoop system basically. Okay, so this one is the motivation, and the approach of the central database data place is not suitable. So data store will become bottleneck if it become inaccessible. Okay, so this one is the motivation for to implement the Hadoop system. And so this is from this slide we can say that it's going to have one server also in going to have the data set facility to make this. I just go through this only diagram. Okay, so it's going to have one server, and in Hadoop ecosystem, Hadoop system, here we have tightly coupled system as compared to the loosely coupled system in that is used in the parallel or high performance computing. Okay, uh, so suppose how can I explain? I just take an example, a real life example to make this how our distributed system is working. Suppose if I am a person, okay, and who is doing work on a particular project, okay, and supposed to do everything in one day. Okay, I require to do all the project related with me to implement in a one day. Okay, and then instead of doing when we are I'm using the Hadoop how Hadoop system is working, I just taking the real life examples. So instead I of doing the entire project by myself. Okay. So what I will do, I just try to find two of two my close friends, or so my students also. I can just divide the task to students also. Sometimes the lecturers are divide the task to their students, the related students. So I just try to find two my friends and distribute my job to uh, they will do their respective job, and then I just distribute them my task, and they will do their respective job, and I will do my part of the job. Okay, and at last when everyone complete their task, then we will combine all the three outputs, and that is the same thing is done in the Hadoop also basically, and we'll do as well whenever the client requests for the high database. Okay, suppose a client requests in the Hadoop system a high database, it is going to with distributed system, and respectively it will fetch from the all the server where the data has been saved using that I have discussed MapReduce tech, technology, and it will be delivered to the end client. Okay, so in the Hadoop system, all the task is divided into their related different servers. All tasks are not performed by using a single server, and all the servers are not are loosely coupled, they or are tightly coupled servers. Okay, so from this real life example, you can easily understand that how Hadoop system is working. Okay, so if I just tracing, I just take tracing it with the uh, Google. Basically, I tracing the Google in 2002 to 2004 from this diagram. You can see that uh, that working 2004, all the working as much as web scale problem based researcher system. So it was in the 2002 and 2003 basically from this from here 2002 and 2003. What will be there? Approximately in the 2003 to 2004, Google published GFS and MapReduce. Okay, okay, GFS and MapReduce. Then in 2004, again, cutting edge BFS and MapReduce uh, are there in Nudge. Okay, in the 2008, okay, Hadoop spins out much in the Yahoo. Okay, and in 2006 to 2008, Apache started to supported the MapReduce. Okay, and SDFS also. Okay, so Hadoop get adapted by the Yahoo team. Then it is the history. Facebook is having uh, 2300 cluster and 40 petabytes of data by the 2010. And in 2016, uh, uh, Apache Hadoop community celebrating with 10 years. Okay, so this is the Google tracing basically from 2000 to 2016. Next, in the next slide, I'll discuss benefits of the Hadoop. Okay, so from this you can easily understand that Hadoop have a computing power. Just some participants are waiting. Okay, so benefits of the Hadoop. These are the benefits of the Hadoop is there. Distributed computing model, quickly process big data. It has a very good computing power. Distributed computing model quickly process big data and more nodes, more processing power is there. Okay. Next, Hadoop provide better flexibility. Okay, it means do not have to pre-process data before uh, storing it, and store as much as data needs to be stored in any format. Okay. Next, we have it provide fault tolerant also means if a data node goes down, jobs are automatically redirected to other data node to make sure the distributed computing does not fail. That is called basically the data tolerant that you have discussed. We have discussed already in computer network also. Okay. Next, we have low cost solution provided by the Hadoop because open source framework is free and uses commodity hardware to store large quantities of the data, which is cheap storage. Okay, uh, clear. So, and then at the last, we have also Hadoop also is provide the scalable benefit to the as compared to the traditional system that where we can see that you can easily grow your system simply by adding more nodes back. Okay, clear. So these are the some of the benefits of the Hadoop. Okay, so from this slide you can easily understand. And for your examination point of view, also these points are very important because sometimes the question may be arise that what are the benefits of the Hadoop, what is the Hadoop ecosystem. Okay, and what are the different component Hadoop ecosystem contain, and what are the different benefits occur due to these by using these Hadoop ecosystem. Basically means we can get a better computing power, better flexibility, uh, the system that is better for good for the fault tolerant. Okay, and that provide Hadoop system provide low cost solution because it use open source framework and also provide scalable database. Okay, so that is more far better as compared to the RDBMS and data warehouse computing. Okay, next we have this one is the Hadoop ecosystem. Already in the previous class, we have discussed in detail all the component of the Hadoop ecosystem. What Hadoop ecosystem contain and what are the different component Hadoop ecosystem contain. Okay, so you just have to go through the previous slide. Okay, from this slide you can easily get all the details of all the components of the Hadoop ecosystem. uh, okay, means like in I just summarize in that particular diagram the role of the each component of the Hadoop ecosystem. Okay, SDFS, we know that Hadoop SDFS is the storage layer of the Hadoop. That is I have discussed earlier in the previous class. MapReduce, that is the compute layer of the Hadoop that performs some computation. Okay, Hive basically one of the data warehouse, okay, Hadoop based data warehouse developed by the Facebook. That is also very much used in the Hadoop ecosystem when we use the Hadoop ecosystem and for a particular business organization. Pig Latin is just like a based language, Hadoop based language developed by the Yahoo. Okay, means that the scripting language basically. Okay. Uh, Next, we have HBase. Okay, HBase, Apache HBase is the one of the software provided by the Apache Software Foundation. Okay, that is also open source software basically. That is also called NoSQL database for Hadoop. Okay, means it just like work as a SQL, means provide a query uh, analysis system basically and support in the Hadoop with the Hadoop ecosystem. Plum is an event and log collector and aggregator. Okay, that is the task of the Plum basically. Myhot is one of the data mining machine learning library. Okay, and SQL Hadoop basically the connectivity tool for moving data between RDMS to Hadoop ecosystem. Okay, we have discussed all the things in previous lecture in detail. And you can go through the YouTube the channel and where I just share the that particular lectures. Okay. Next we have a Zookeeper. It is a high performance coordinations and that is used for the distributed application. Okay. OZ is a workflow and coordination service to manage data processing job for Apache Hadoop. Okay. So next, we'll start. We have discussed in detail Hadoop ecosystem, and in the next that we have in that particular lecture, we have to require to start the discuss and understand the Hadoop architecture. Okay, one by one, all the components of the architecture basically. Okay, so let me start with the very first storage system, the component of the Hadoop SDFS. Okay, and the last time also we have discussed and what is SDFS. We know that it provide fault tolerance transparency because and it is called the full form of SDFS is Hadoop distributed file system. So what is SDFS? We have discussed earlier very well, and from this diagram we can see that. Let me start. It is just like a simple file system, and it is inspired by the GFS. Okay, that is the tool of the Google that we have seen earlier in previous slides. Okay, and designed for very large size data set. Okay, and stored on a cluster. Okay, because it is stored the data in the form of the cluster. Okay, and develop on the idea of WARM. Anybody have idea what is the meaning of WORM? Hadoop HDFS file system is developed on the idea of WARM. Anybody have idea? WORM. So anybody have idea? Then you can just write down in the chat box because Hadoop SDFS file system is designed on that particular idea. What is WORM? No, no, we are not discussing about the security and cryptography here. Uh, Actually, we are discussing. Actually, you just have to go, think in the way like we are fetching the data from some of the storage, and after fetching some after performing some analysis and some we are generating some reports because big data analytic we are discussing. We have to focus only on the database, data warehouse, on that particular thing. Security also is there, but in detail we'll discuss further because security is also concerned with the big data. Okay, so WORM, write once, read many, read many times. That is a very okay means this one is the correct. Okay means that SDFS is based on the idea of WORM. Okay, so what is WRM? So it is write once and read many times. Okay, so data set is copied from a source, then a parallel analysis is performed at local data set commodity hardware and will do for the SDFS setup. And application expect low level latency of data will not work with the SDFS. Okay, so SDFS break incoming files into blocks. Okay, and store them redundantly across the cluster. So it provide reliable, scalable, low cost storage. Okay, so talking about SDFS architecture, data is organized into files. Means suppose this one on the left side we have a data, and this data is organized into files and directory. Okay, and the files are divided into uniform sized files. Basically, from right side you can see that 1 to 5. Okay. This one left side we have a files and that is organized in the files and directories, and these files are divided into uniform size files basically, and so from here you can see that 245, 125, 134, 235, 135. Okay, so these all are the basically the uniform size blocks or uniform size files. Okay, these files are divided by using the SDFS in the uniform size files. Why this task are performed? Because it is provide how it provide a reliable, scalable, low cost storage. We will see. Okay, because small sizes blocks are there, so ultimately low cost storage is there, and distributed across the cluster nodes. Okay, now these are the clusters. Okay, all these files are uniform size files are divided into cluster nodes. Okay, so SDFS is mounted on a top of the local system. Okay, because it work on the top of SDFS is top work on the top of the Hadoop ecosystem basically. So you can see two is here. Okay, in the left here you can see now. Okay, so two is here and two is also in the second cluster. Two is here and five is here in the first cluster and five is here in the second cluster. So if one of the node is failing, suppose one of the node is failing completely, okay, then can have a backup of 2 and 5 in another nodes also. Okay, clear? So it provides reliable, scalable, and low cost storage SPFS. Okay, so in the next class, we'll discuss in detail about what is master worker architecture and what is the map reduce. Okay, so if all of you are agree for to take the class for 10 to 15 minutes more, then yeah, I just if you all are agree, then you just send your consent. Then I'll just want to discuss 3 to 4 slides more. Okay, but due to limitations of this freeware online lecture tools, I just have to require to uh, one just end the meeting and then again restart the meeting. So if anybody all are agree, then I'll just want to take 10 to 15 minutes more, basically. Okay. So I okay, so further we'll discuss some more about the architecture of the SDFS Hadoop architecture. Okay, so all are agree or not? Otherwise, I'll start tomorrow. Okay, okay. Okay. So I'm just starting after 5 minutes. You just have to wait. Okay. Because some recording is also there. We have to require to keep the recording of these sessions. So it will take 5 to 7 minutes. So after 5 to 7 minutes, I will start again that meeting. Okay. So I just end the meeting and further I will start the next about the Hadoop architecture.